All right, so in today's talk, I'll be walking through our experience, essentially starting with the Raspberry Pi in the early days, and I'm going to walk you through exactly where we started, how we came to be, and then basically do an outlook on the future and where we are and how we move forward. So before we begin, let me just start with a big disclosure. I'm not a hardware guy. There will be people in here that can grill me on things I have no clue about, but it's going to be more like a high-level talk about our experiences from my vantage point of what we've learned so far. And so quick on me, I'm a serial entrepreneur, done a few businesses, and really more like a DevOpsy nerd, more so than a hardware nerd. And also a quick shout out, I just started a podcast called Nerding Out with Viktor, which I interview a bunch of people like the Coreboot guys that I will speak about later in the talk. And I'm the founder of a company called Screenly, and the reason we exist is essentially to prevent this from happening. So we do something called digital signage, which is really just a fancy term for saying display management. And we built this platform that powers thousands of screens around the world, and we ensure that they are secure, essentially. So that, of course, comes with a hardware component, and that's what I'll be speaking about today. Most recently, we introduced something called Edge Apps, and we started doing retail signage, and so basically these screens you see in advertisement around the world. And we've now kind of transitioned the company to be a more developer platform. So we now launched what we call like an operating system for screens, or a screen operating system within quotes. And the idea is to basically power everything from POS systems to self-checkout counters to ATM and anything in between. And the really reason why we created this, because we spoke to a lot of companies out there. And if you look at the hierarchy of what it takes to run a screen, this is essentially the stack. So you need hardware, you need operating system, you need a device manager, an app distribution. But the only thing that you as a business care about is the actual value on top, what is actually running on the screens. The rest is busy work. But if you neglect that busy work, it will have real life implications. Compromised screens, attacks for various defamation, and all sorts of nasty things that will cause you headaches. So over the last decade, we built all this stack, power thousands of screens around the world, and then we opened it up to developers. So Edge App, just real quick, it's a web-based framework. It runs locally on the device. It's an ephemeral runtime environment that's written in JavaScript that gives you metadata. You can plug in hardware sensors to devices, embedded temperature sensors or proximity sensors. All those things are built in. And so that goal is basically so you can focus on the actual application stack, and that's really what we try to do. So let's take it back and see how we get started. So we started back in 2012 over a sequence of events. Me and my co-founder ended up buying a failing digital signage business in Sweden. So overnight, we had 12 or 15 screens with no software, just the hardware. And we were like, being geeks, we were like, well, how hard can that be, right? It's just a screen, can't be that hard. So between Christmas and New Year's, we went deep and I started writing a prototype, basically bash scripts, used a lot of fancy, cool Unix tools like cronjobs, rsync, and mplayer, and essentially it worked. It was not pretty, but it worked. And as for the actual hardware, we started with this guy. I'm not sure, anybody familiar with this box? Anybody remember them? Yeah? This is like the sibling of the Asus EEPC, which was probably the first affordable netbook. And it was pretty cool when it came out. And frankly, it was a good device. I still have some of these running, and they're actually pretty good. But they're essentially $300 to build. And they're just showing images on slideshows, so it felt a bit excessive. We ran Ubuntu 12.04 on them, and it worked pretty well. Like, it did the job. But we realized we could shave off cost. So we wanted to explore the SoC path and start building our own boards. But back in those days, if you wanted to do your own SoC or SBC, the MOQs were tens or hundreds of thousands of units. So as a small company, completely unrealistic to actually pull off, right? But then something really interesting happened. March of 2012, this little thing was announced, the Raspberry Pi, the very first version. We immediately jumped on the waitlist for the first Raspberry Pi, and I think I got my delivery in June 2012. And we realized this was a big game changer. Because now, instead of having a device that cost $300, we got a device that cost $35. And obviously, it's a massive difference in price, and you got to deploy this at scale. So we immediately started porting our software stack, the ugly bash scripts, to the Raspberry Pi, which turned out to be relatively easy, because it's just Raspbian, and instead of MPlayer, you could use OMX Player. So it worked pretty easy. It took probably like a week or two to port everything working. And then we decided to open source on GitHub. So we put it on GitHub, announced it on the Raspberry Pi forum, and it really just exploded. We had so much traction, because remember, this is the first version of the Raspberry Pi. The first cohort of people just got the Raspberry Pi. So a lot of people got them, and they were like, now this is really cool. What do I do with this? And we offered like a real concrete use case for them. So it really shot off, and we got a lot of traction in the early days. And I think about a month or two after we announced this on the forum and on GitHub, we got contacted by an ATM vendor in the US. And they were asking to deploy this across 10,000 ATM machines in the US. And we're like, we never thought of this as a commercial project. We always thought, like, well, we're just solving our own problems, but we're open sourcing it in process. But after getting more and more of these, we realized that actually, no, we need to actually take this and do something with it. So we kept pushing more into this, and we added a management layer, and eventually the two products between the open source version and the commercial version kind of diverged fully. But they are still maintained, both of them, separately. But as you can see here, that is the start trajectory on GitHub. And to this day, it's, I think, order of magnitude 3 times larger than the next biggest digital signage project on GitHub. So it's pretty active. Haven't really gotten to where we want with it yet, but it's pretty active and it still works. And we don't even know how many people are using it, because it's fully open source. We don't really have any tracking. So we know it's popular, but we don't really know a lot about the exact use cases. Now, let's go back and talk a bit about hardware. I mentioned we start with the Raspberry Pi. So let's look at the Raspberry Pi performance over time, right? So if you look at the graph, this is just the Geekbench data, so the CPU score, essentially. And we started with the Pi 2, because I couldn't find any data on the Pi 1, and I didn't really want to get my Pi 1 up and running. And if you look here, Pi 1, Pi 2, Pi 3, Pi 4, Pi 5, roughly every release is 2 to 3 times faster than the previous release, which is really good. That's pretty cool. And we are today using the Pi 4 for our entry-level player, which is Raspberry Pi based. So this is our Screenly player, as we call it. And it's essentially Raspberry Pi 4, 4 gigs of RAM, with some modifications. So it has an industrial-grade SD card, which is really important, because if you do anything Raspberry Pi, absolute first thing that's going to break is going to be SD card. That's always the first thing that breaks. So we use basically the best SD card you can buy. And they are expensive, but way worth it. The next thing is the entire thing is a heatsink. So it's a heatsink case. So they're pretty expensive. And then in our bundle that we sell to our customers, we include all the cabling and all that stuff. So it comes with adapters, it comes with all the things you need. But whilst the board itself is still pretty cheap, once you add in all the accessories, you're approaching the $200 mark for a single device. So it's no longer by any means a $35 computer, it's more like a $200 computer once actually you starting using it. All right, so that's what we're doing today. Let's look at like what experience has been so far. We already talked about the SD cards kind of being a challenge, but I must say the board itself is extremely reliable. I think over the 10 plus years we're doing this, I can probably count on one hand the amount of boards we've seen breaking. Like, they are extremely reliable. Now, it's not the problem with the board, it's the problem with the things that goes into the board that tends to be the problem part. So when we look at this, the first thing I already mentioned is lack of storage, right? So SD card, yeah, it does work, but the life cycle of these devices, they will eventually break. We expect, even with the best SD card money can buy today, well, within reason, 2-3 years is the absolute upper limit for how long they last in a real life environment. Like, we've seen somebody live longer than that, but That's roughly a pretty decent 2 to 3 years, a reasonable time frame for like a realistic usage of these. The next one is the lack of RTC, real-time clock. And that's a big problem if you're actually using this for real network workload. So security is one of our big spiels. So we do a lot of cryptographic operations, and obviously if you don't have the time set properly, nothing works. There are workarounds for this, but it's a bit nasty because you have to keep track and set it from disk and whatnot. So it's a bit nasty. The next, the lack of TPM. That's actually something that is a real problem for us, because that means that we can't really do anything secure on the device. Because where are you going to store it if you can't encrypt it? Sure, you can have a key on the SD card, but what's the point of that? Like, you can still just rip it out and read the key. So it's kind of false level of security. And the obvious question then, anybody who's been playing with the Raspberry Pi community thinks like, well, what about the compute module? It's the obvious answer, right? Kind of. Because if you look at the carrier boards available today for the Raspberry Pi, I'm not talking about the dev kit and all that stuff, but the proper commercially viable ones, there aren't that many out. So Balena had their Fin, which was pretty decent, but they now discontinued that. There is a Rack just introduced. I think I spoke to Rack guys last week. They've introduced a new dev kit, which is actually pretty cool. So that might actually be something worth exploring. But the reality is that it probably won't tick all the boxes for us anyways. So we might actually have to go back into the kind of drawing board and see if it's possible now, in this day and age, to actually do our own board and do kind of open hardware on that. But it's something we're still exploring. But everything was running really well. And we were pretty happy with the Pi and all that. But then COVID happens, and we can no longer source Raspberry Pis, which is kind of a big problem because that's our business. So we ended up realizing that, okay, we can't buy them. When we could buy them, we had to buy them on the secondary markets. Like now we have a relationship with the Pi Foundation, so we have earmarked allocation and whatnot. But before then, we ran dry. We literally could not get them to our customers. So, which is obviously a big problem because then our entire business grinds to a halt. We ended up buying a lot of them on the secondary market at massive premiums, right? Which is kind of fine for us because we make our money back on subscription licenses, but we were paying like 2, 3, 4x what it would cost before COVID for a single device. So the guys thinking, should we kind of branch outside of the Raspberry Pi? Have we just been blindsided by the Pi? Should we actually look at other alternatives? And what we ended up with was actually this little thing, which is we call the Screeny PlayMax. And it's a NUC-style computer. It's not an official NUC, as you can see. We sourced it from China directly, from manufacturer, from an OEM in China. It's an Intel i3. It's a 10th gen, 128 gig storage, and 8 gigs of RAM. Fanless, has all the things that I mentioned before. It has a TPM, it has an RTC, and it also has proper storage, of course, and external Wi-Fi antennas, which is very handy when you're deploying over Wi-Fi in a real-world environment when, as you probably know, in the real world, Wi-Fi is flaky at best. And we can start doing things like secure boot, which is really nice when you actually want to protect your environment. So how does this stack up, right? So we already reviewed this graph before. We have the Pi 2, Pi 3, Pi 4, Pi 5. Cool. This is how the Pi 5, our PlayMax stacks up to the Pi 5. Remember, it's an i3 10th gen, so it's not hardly a new i3. It's an it's an old generation i3. Now, here's the kicker. We sell this for $369. And we sell the Pi 4 for $219. So for less than half the price, we can 5x the performance to a Pi 5. And I must say, I was really surprised by that, because I thought the Raspberry Pi would be far more cost effective than it actually was, but it really isn't in this day and age. When the very first Raspberry Pi came out, it was a game changer. Today, not really anymore, unfortunately. All right, cool. So we've now ventured down the Pi route, we ventured down the x86 route, but we're not quite happy yet, because the x86 board, it came with its own set of challenges. So one of the big things that we ran into early on was the FDE didn't really work, full disk encryption didn't really work, and that was due to the implementation of the TPM. So we couldn't get that working, at least on the Ubuntu core, we couldn't get it working. And that's kind of a problem for us when we sell it to enterprise, because we really want to make sure we secure that properly. So there is room for improvement in the hardware. So we started thinking like, okay, there are definitely scope to improve in the next iteration. I'll come back to how our view look for the next generation of our Max player in a second. But before we do that, I'm going to speak briefly about BIOSes. Because I don't think anybody really thinks too much about BIOSes. I must say, I had not thought about BIOSes for a good 10 years before we started scoping this. Because like if you're on a Mac, like you don't even know what a BIOS is. Like you don't really touch it. But I started thinking more about BIOSes. And it's really this black hole that you don't really have any understanding of, like the software for. And if you can compromise the BIOS of a device, it's game over. Like nothing you can do in user space is secure anymore. Because you can tamper with any cryptographic operations. You can backdoor the RNG. You can backdoor a lot of things if you got access to the BIOS. And I'm not sure anybody in the room dealt with any ODMs or OEMs when you do BIOS provisioning, but you don't have much control, and you really do not know what happens behind the scenes. You basically say to them, do these configurations for us, and then you get a blob back. And you're like, cool. I have no idea if I can trust what's in there. So we started looking at that, and I started really like, I don't really trust this workflow at all. Because again, if you backdoor that, like it's game over. And there's a long chain of people, stakeholders involved, that each of them could actually backdoor a TPM, for instance. Particularly if you make it in China, like I don't know. I didn't really feel good. And even when we do get a new version of these, like there's no change log. There's no such concept, it's just a blob. That's how you get them. So my kind of worst fears got realized in December of last year when LogoFail happened. I guess most people in the room are familiar with LogoFail. Most BIOS vendors were affected by this, or at least AMI were affected, and Phoenix and a few others were affected. So many of the big BIOS vendors were affected by this. And the way it worked was that you could, using the logo, the splash screen for the boot logo, you can exploit that into basically compromise the BIOS. So secure boot, all those things, void. You basically bypassed it. So terrifying, right? And if that wasn't bad enough, 2 weeks ago, another one of these hit. There's not one new one called PixieFail, which found the new exploit in the PXE boot. So now we've had, over this past scope of what, 3 months, we've had 2 super severe BIOS vulnerabilities. And that really, hopefully, will drive some more attention to BIOSes and actually start paying attention to that. But there's still hope. So it's something called Coreboot. And it's a project that started gaining momentum in the last few years, I would say, but it's actually a real old project. And it started out at Los Alamos National Lab in the US, where they had an issue with their big clusters because they were using commodity PCs for their big clusters. And obviously, if they're running racks of servers, they don't have keyboards plugged into them, but they were using off-the-shelf PCs. So every time they had to reboot the cluster, they had to send out an army of PhD students to basically press F1 on each and every one of these nodes to make them boot. Not a great scenario, right? And these were early days clusters, so they had to reboot fairly often. So there was actually a massive problem. So the original Coreboot was called Linux BIOS, and essentially ended up initially to solve that problem, but has today grown to a much, much bigger project. And if you own a Chromebook or a Chromebox of any sort, or at least x86, your Chromebook is most likely running Coreboot today. So it has gained a lot of momentum over the last few years, in particular from the security perspective. What's really cool about Coreboot is that it's open source. It can generate deterministic builds, so you actually know that this actually is legit. So you know that actually it's solid because, well, you have the hash, you can actually run everything yourself. And there are even tools available out there for doing SBOMs for that. So you can generate an SBOM for your BIOS, which is obviously super cool because now we actually understand. And if you are interested in learning more about Coreboot, I did an episode on a podcast where I interviewed two of the core founders, core maintainers for Coreboot. And it's a really, really cool, David Hendricks and Matt DeVilliers really had cool insights on Coreboot in general. And I'm really bullish on that project, so I'm really going to keep a close eye on that. All right, so we talked about a little about Coreboot and all this stuff, but let's look about the landscape for this. So there are some companies out there that are really leveraging this. So Purism System 75 is actually, 76 is actually not using Coreboot for whatever reason, but Protectly, Star Systems, Star Lab Systems, sorry, Nova Custom and Planet Compute, they are all big fans of Coreboot. So there are good alternatives out there. But okay, so you got your BIOS, you can build the BIOS, it's open source, you can patch it, that's really cool. All right, but what good is a BIOS if you can't actually deploy it? Because if you still require somebody to go out with a USB stick to patch this, that's kind of completely unviable if you actually deploy at scale, right? Well, there is a little fun project called FWUpdate. Is anybody familiar with that project? All right, cool, at least one hand or a few hands up there. Anybody actually used it? Okay, a few people use it. Oh, that's cool. All right. I think it has more. Oh, right, okay. Cool. I missed that, but yeah, it's a really cool project, and it can use for firmware update, not only for BIOSes, but for firmwares for all sorts of hardware, right? And some vendors have already adopted it. So Lenovo for some devices, I know Dell has it for some device, I think, but it's hardly like well deployed, right? They won't have 100% support by any means. But what this means that if you combine this with Coreboot, you end up with a scenario where you can actually, at scale, like we are doing, we're not doing it yet, but we want to get to it, deploy at scale BIOSes to like tens of thousands of devices over the air. And that's really cool. So that's really what we are looking at in the next version to get to, right? All right, let's turn the table to something that I know is on every hardware person's mind lately, which is RISC-V. And yesterday we saw quite a few talks about RISC-V. And I was very excited about RISC-V until I started speaking with people in the RISC-V world. And the short answer is RISC-V is really, really promising, and I think it's going to be great. But today, the use case of RISC-V is more for like small MCUs or like super low resource things. And for our use case, unfortunately, we are probably like 5 years out until we can even get close to where we want to be with this. There are some interesting things, but I think Sci-Fi got a few interesting boards that could be interesting, but generally speaking, they're not designed for this use case yet. They're more like low power devices. All right, cool. So what about open hardware? A misconception that I had, at least, was with open hardware was that, well, RISC-V is open hardware, right? Not really. Not at all. Most of the vendors that are pushing for RISC-V, they are doing it to get rid of their ARM licenses prices, really. They still want to make sure that it's closed sourced and there is nothing open hardware-esque about that at all. It's purely to get rid of ARM to a great degree, unfortunately. So I think if you're going to be a purist about open hardware, so meaning as in no proprietary blobs at all, I think at the moment, at least for our use case, that's a pipe dream. And I heard someone estimated that if you want to have a fully open source GPU, for instance, it's probably about 1 million man hours to make an open source GPU. And I don't see anybody doing that anytime soon. So I think the vendors will be keeping their secrets very closely guarded for the foreseeable future. All right, so we kind of talked about the background, we talked about a little about that. So as we are looking forward to the next generation of our player, the screenly PlayMax in particular right now, I'll start with. Here are the things that we are looking at, right? We want to do Coreboot with firmware update or FWUpdate. And we probably would not be able to get to open hardware because I don't think it's realistic. We are exploring options for CPUs. So we're exploring AMDs in addition to Intel's to see if that's a better option. And one thing we realized as we've done the scale now, one thing we're actually really missing on our board is a hardware watchdog. And you see them in embedded system, but you don't really see them in x86 system these days, unless you go to like industrial gateways. But that, we've seen scenarios where like systems properly lock up, where they really, even a software watchdog cannot actually get you out of that. We're also exploring 5G support, so we can actually have these fully connected, kind of tying into the last talk. And then we really want to have GPIO support, because that's something that would really work well with, I was talking about the edge app platform, so you can plug in sensors even on the x86. And finally, on our Raspberry Pi side, we are exploring alternatives. It's not cost effective anymore, I must admit. So until RISC-V becomes ready, because in a perfect world, we have RISC-V player as entry-level player, and when we have an x86 for like a more powerful device, until that reality becomes true, we're probably going to look into more MediaTek and Rockchip, because I think they are far more powerful and far more cost effective. It also comes with the components that we actually need. So that's kind of where our head is at right now. I know these guys are hardly open firmware or open hardware, but I think it's a much more cost-effective play today than Raspberry Pi, unfortunately. And those are my slides.